Welcome to CS179 Networking 1 Module 8. I am your instructor, Robert McMillen, and we're going from the book Managing and Troubleshooting Networks by Mike Myers. This particular module, we're going to talk about wireless networking. And that's going to include access points, power over Ethernet, antenna types, topology, and security. Let's talk about access points for a minute. So access points are used instead of hubs and switches in a wireless environment. So in a wired environment, of course, we plug all of our computers together into a switch, and that is going to be sort of our backbone of our LAN. And wireless access points don't work that way. We all connect to our wireless access points as the wireless backbone, but of course at some point it's going to have to be wired. So you can actually go wireless up to the access point, but then the access point has to be wired into the switch after that. The access points act as a repeater. They must be able to hear all computers on a wireless local area network. So that can actually cause some security issues, which we'll talk about later. So let's take a look at some of the different access points. This is an access point on the left for small office, home office use. And of course, they've got the antennas set incorrectly. They should be pointing straight up or straight out, depending on if it's lying on a table or mounted on a wall. Never have the antennas going sideways, because that's not the way that the waves actually appear. The waves need to go in regular circles. So let's take a look down the right. We've got a power over Ethernet access point. And so this one has the antenna built into it, so you can't mess it up. And you see a connection with an Ethernet cable. You don't see any power connection. And that's because it's getting its power over Ethernet through the Ethernet cable back to a PoE switch. So a PoE switch, it's used to supply power to certain access points that have that kind of capability. There's no external power needed because it uses so little power. It can be provided by the switch itself. And it's being used over the Cat5 wires. So you can both connect to your switch as well as power your access point at the same time. Of course, your switch has to say it is PoE capable, and then you have to configure the port for the right voltage in certain situations. In other situations, the default voltage works fine. So let's talk about antennas that are used in a wireless LAN. And there's a few different kinds. You have the omnidirectional antennas, which transmit in all directions simultaneously. It's used in most wireless networks. They use a dipole antenna, and it transmits in all different directions. Then you have directional antennas. It projects the signal in only one direction. It's very focused. You end up with a stronger signal because of that, and it will go farther as well. But of course, if you need to have it go in different directions, then you're not going to get that because it's just directional. Most often used inside of an exterior wall. So if you're going to be in a corner, this is a great place for a directional antenna. And you can also make antennas from various different things that are not standard, such as from Pringles cans and other things called cantennas, which uses the foil on the inside of the different can that actually helps project the wireless access point. So types of antennas, directional and omnidirectional. We just talked about those. This is a graphical version of those two different types of antennas. And wireless Ethernet uses radio frequencies to transmit the signals through the air instead of through cables. It comes from the 802.1, actually it's the 802.11x family standard, also known as Wi-Fi. Wi-Fi, of course, is growing in popularity. It eliminates cables and facilitates network access from a variety of locations. Great for mobile workers, so you can pick up your laptop or your tablet, move it anywhere, and still continue to have access to the network. And it's currently used in 90% of all companies. The downside to that is that the wireless spectrum is very, very small. And if you continue to grow in this area of Wi-Fi, where everyone's fighting for that wireless space, then we're going to have nothing but problems as people try to connect and they're stepping all over each other. So it's very similar. A wireless access point is very similar to the star type of setup. You have the Ethernet switch connected over to the access point, and then they're all connected to it. Now, it's also similar to the logical bus setup. So the bus setup we talked about in one of our first modules, in that it's possible for all computers to listen to each other's traffic, since they're all passing over to the same access point. So that is definitely a security issue, which we'll talk about a little bit later. This is definitely a quiz alert. Wireless LAN uses CSMACA. Now, we talked about CSMACD in one of the earlier modules, which is collision detection. Well, wireless LAN uses collision avoidance. So a station waits until another station is finished transmitting, and plus an additional random amount of time before sending anything. So it keeps from colliding with other ones by waiting for everyone to take their turn. The bad part about this is that, of course, it's much slower, but the good part is you don't have the collisions, which can be devastating to a wireless network. So in order to connect to an access point, you've got to have an association. So when you turn on your computer, your tablet, whatever device it is that is on the client side, it scans for available access points. Well, there's a couple different types of access points that could be listening for those scans. One is an active access point, where the network interface card transmits probe frames on all active channels. Of course, they both do that. And then the access point responds with info to say, hey, here's my information to associate back to you. A passive one also listens, the NIC also listens on all channels but for a beacon frame. And then the NIC can use info in the beacon frame to associate with an access point. Of course, the active is going to be better than the passive one is, but the active one is going to be more expensive as well. So the wireless LAN characteristics, there's two different ranges. There's 2.4 gigahertz and 5 gigahertz. And the distance range is anywhere from 100 to 150 meters, but that's actually not realistic. If you have a lot of different doors and windows and things like that, then this could greatly reduce the distance that this can go. So one thing about wireless or Wi-Fi that a lot of people don't realize is it's based on line of sight. If you don't have a line of sight between your computer and the access point, or between two different access points, then what happens is the access point has to bounce off the floor, the walls, the ceiling, all different places until it finally gets to your device. And by the time it gets there, it may be greatly diminished in speed, or it might be too weak to connect at all. So the 100 to 150 meters is if there's nothing in the way and the two devices can see each other because they're in their line of sight. It also uses channels to reduce the amount of interference. And those channels basically rotate if you set the access point to automatic. So it'll find whatever channels use the least, and then your device will scan those channels for that SSID, which the access point is now broadcasting. So let's talk about the different amounts of channels and other things that come with the wireless experience. So there's various different 802.11 wireless or Wi-Fi standards. The first one we're going to talk about is the A standard. So it comes with 8 separate channels. That means that these channels cannot step all over each other. It's now at 54 megabits. When you may be wondering, why is A faster than B? And that's because this is the second iteration of A. The original A was only 2 megabits. And now they came back out with a new A, which is 54, so it's much faster. The range is fairly short. It's only 50 meters. So if we go down to B, B is one that's rarely used anymore. It has 3 channels, although they say that it has 13 channels. The reality is just that the channels sort of overlap each other. So there's only 3 channels that don't overlap each other, 1, 6, and 11. And the maximum speed is 11 megabits, and it can go a lot farther, but it just can't go as fast. G is a similar situation as B. It only has the 3, 1, 6, and 11 channels. That's a quiz alert, by the way. And it will go at 54 megabits per second, and it'll go up to 150 meters. So it's a very good speed. Most every device nowadays has the G capability. Most of them have dropped off the B and A bandwagon, but it's certainly possible that if they come up with new iterations of A and B, that they may get popular again. However, I don't think so, and that's because a 802.11n came out a few years back, and they finally settled on a standard for N. That for a long time it was there were two different standards, and they finally came down with one that most of them use. So if you use the 3-channel option, you can get 200 megabits. If you use the 1-channel option, you can go with 600 megabits up to 150 meters away. However, again, you do have the issue of Wi-Fi does not pass through walls, so you have to have some sort of line of sight or bouncing off of things in order to work. And it bounces off shiny objects much better than it does things like carpeting. Now, the latest one, which is not in our book, is 802.11ac, and that is gigabit capability. We don't have all the different specs as far as the channels and the max range. You won't be tested on it, but I just thought I would throw that in there because it is a new standard that a lot of people are picking up, and I'm sure it will be in the later versions of the book. So let's talk for a second about the 802.11n standard. It is backwards compatible with A, B, and G. So if you get an N device, you can also have A, B, and G typically also work if you have clients with those devices on them. So one disadvantage is if you do decide to broadcast your N access point on anything else other than N, such as A, B, or G, then as soon as somebody connects using one of those other ones, it will diminish the speed of N. It just is not that greatly compatible with the older standards. So I recommend that if you do N, you only do N. If you do G, you only do G. And if anybody can't connect, then you upgrade their equipment. That way, the rest of the company doesn't have to suffer because a few people are on older technology. So the type of security we have is, to start with, you have the SSID. Now the SSID is the different name or number that comes up when you start searching for your different access points. Some SSIDs are hidden by default, whereas others are being broadcast. It's really up to the network administrator to decide whether or not those are going to be broadcast. One of the types of security is called wired equivalent privacy. Now, that particular type uses a key that never really rotates. It's easy to break. It's not recommended. It's only used in really old technology, and you should not use it in your network. There's also Extensible Authentication Protocol, EAP, which is a one-time WEP key created dynamically after a login. Requires login with a password to a server. So EAP can be used with WEP in order to add additional security. But again, don't recommend it. Wi-Fi protected access, that's a newer standard, which is a longer key, and it gets changed, it gets rotated. But again, it has been cracked, so they came up with WPA2, also using EAP to get a session key, and it uses the Advanced Encryption Service, AES, in order to do the encryption. So the only current wireless technology that we believe has not been broken, we don't have confirmation of that, but this is what we believe, is WPA2 using AES. That's the only accepted secure protocol for businesses should adopt. MAC address filtering allows computers to connect to the access point only if their MAC address is entered in the accepted list. So this is another way to keep people off of your network. You don't want them. You can say, hey, only these particular network interface cards, you get the MAC address off of them, are allowed to connect to our device. So if I do an ipconfig /all, it'll actually give me my MAC address, and that's also referred to as the physical address. So here's my physical address right here. That's my MAC address, and I can paste that into my wireless access point and say, hey, if my number is here, then you can let that one in. If it's not there, you don't. And so that's a good way to secure the network. So in conclusion, we talked about access points, power over Ethernet, antennas, topology, and security. So stay tuned for our final module, Module 9.